Everyone has a different story about what draws them into their careers.
I do remember very distinctly being able to, at the age of 7, stay up and watch that first moon landing. It made a huge impression on me.
Growing up and seeing the real footage of spaceships and the promises of outer space, with my impatient personality, it was taking too long. And I think because of that, I wanted to get there faster and I got interested in films.
I've talked to many engineers in different fields, but at NASA in particular, why are they doing what they're doing? They were inspired by science fiction that they saw as a kid.
Star Wars has been one of the great inspirations for NASA. I myself kind of got excited about the cool things that we can do a long time ago because of Star Wars.
I remember when I was a kid walking to the movie theater and just seeing, those famous words on the screen a long time ago in a galaxy far, far away, and I just wanted to be there.
It's our job and our privilege to make science fiction real.
The vision for Spheres started when one engineering professor saw Star Wars, and it made him think, why can't we make that real?
I was the teaching assistant during the class where we built Spheres. My advisor, Dave Miller, he actually asked me if I had a video of Star Wars. I'm like, of course I have a video of Star Wars.
Here is this, serious MIT professor who is a big little kid that loves to think about what could be.
So we get to the class, and he told me, okay, cue it to that part with the Millennium Falcon, where Luke Skywalker is training with a lightsaber, and there's this little thing flying around, and he basically says, build me 3 of those. Students are like, really?
Spheres provides a general platform in microgravity for investigators to perform research.
They're little spherical satellites like soccer balls, and they have a control algorithm that can drive it around in any orientation.
This is a sphere, and it has a tank of liquid CO2 at the bottom, so when it's in space, it can move itself around.
It can stay at one spot and, on an instant's notice, maneuver itself in any direction, up, down, left, right, forward, back, and it's also rotating in any given direction.
And we put various things such as cameras, computing on board it to make it into a robot.
STEM is science, technology, engineering, and math, and it's the area in which we as a nation really should put a lot of our effort into to help young people get into those fields.
Zero Robotics is a programming competition that ends in space.
Thousands of students down here on the ground can have their software performed on the space station, and the astronauts up there are going to actually let those satellites fly around inside the space station.
I think it's really amazing to think that we've reached a point where something that comes up in a movie we're able to do on a spaceship, and able to control something like that from high school. We're able to do it and program it to a point where it acts by itself. That's a lot like what's happening in Star Wars. The next thing we need to do is just get it to shoot lasers.
NASA already, in fact, uses blasters. There's a thing on the Mars Science Laboratory called LIBS. It's basically a laser beam that blows up rocks, and then we can look at the vaporized material. When that shows up on something like Spheres, maybe in a few years.
Now, there's all these students in Zero Robotics who are eager, they are hungry to work more in space.
It makes them realize that the future is basically unlimited.
There's many reasons why we want to do a lot more robotics in space.
Just looking at what the Star Wars movies provided, there's a lot of droids, there's a lot of human assistants that make part of that future.
A robot like R2-D2 is something that appears to have consciousness. What you really mean is it has autonomy. It can do things by itself, and a lot of things by itself. I would say probably in a decade or so, autonomy that begins to look like what we saw in R2-D2 could exist.
At ILM and at Lucasfilm, we've always pushed the technology to create imagery and sounds and all that you've never seen before.
A big part of the ethos of the company is questioning the status quo, asking yourself, is there a better way?
And that really is what has gone on in the space program, so that everything's kind of paralleling. It's part of the dream that people have of advancing themselves.
The NASA story is a human story. It's an inspiration story, and people are fixed on the fact that human beings can push themselves to those limits and beyond.
The fact that this is an experiment that started off as someone's vision in a movie, which turned into someone's vision as engineering, and there it is on the space station, and then inspiring students who will do who knows what with it.
When I see anything that is for real, it's something that we did in a film, it's pretty amazing to think that it could have an influence.
This is the next big step, is to have robots working with people in space, our astronauts, to do things they couldn't do before. And very, very exciting effort, and it's the way we're going to be expanding as we go to Mars, as we go to asteroids, and we go beyond.